Hi everyone, happy Monday, March 23rd. Today we're going to be talking about tables and equations of proportional relationships. And as I was working on this, I realized it was really similar to what we did on Friday. So if you haven't done Friday's lessons yet, you could look at that to help you get started. You can also continue that practice in connection with this. But this is a little bit more of a focus on looking at tables. So, to start, warm-up question. What is the capacity of the cylindrical vase next to that Diet Coke can? I will give you a hint that cans of soda like this are 12 ounces. So if that's 12 ounces, how much water do you think is held in that cylindrical vase? I will reveal the answer at the end. Okay, so today, again, we're looking at tables and equations of proportional relationships, really similar to what we did on Friday. And just a reminder, the constant of proportionality is the constant multiple that relates quantities x and y, meaning we have two variables that we're dealing with, and it's the multiple between them. And we use the letter k to represent it. Same as unit rate. So the problem that we're going to look at first has to do with a place that I love to go to in Green Lake. I think you say Kitanda? I'm actually not sure how you pronounce the store, but it's in Green Lake, kind of like, it's by the main Starbucks in Green Lake, back with all of those stores right across from PCC, if you ever want to go there. So they make acai bowls and other things, but I love acai bowls. They're like, acai is kind of like, I mean, it's a fruit that they make. It's almost like a sorbet kind of, because it's frozen. Anyway, and you can see topped, my favorite one is topped with peanut butter, banana, strawberry, granola, Brazil nuts, and honey. It's so good. So our question is though, so the description right there is one set price. But then if you want to add on other toppings, it's an additional cost per topping. So like to add more bananas, 85 cents, coconut chips, 85 cents, dried mango, 85 cents. So my question then is, if we change this to be a table, our extra toppings are 85 cents each. So what we're going to look at today is, based on this table, what is the constant proportionality, and what's an equation that we could write to find the price based on any number of toppings. So if we look at this with connection to our definition, the constant multiple that connects x and y, so the extra toppings is going to be our x, and the price is our y, because the price depends on how many toppings. So if I buy one topping, it's 85 cents. So 1 times 0.85 is that 85 cents. 2 times 0.85, wow, can't write, is $1.70. And that pattern continues. So the constant multiple that represents x and y is 0.85. That's our constant of proportionality. You can figure that out by doing y divided by x. Because if we do $3.40 divided by 4, you'll get 85 cents. So you can also see the unit rate's 85 cents. Remember, the constant proportionality is the same as the unit rate. So this 85 cents is showing up in a lot of different ways in our table. The way you write the equation then is that the price, y, is always equal to 85 cents times x, the number of toppings. So the constant of proportionality, 0.85, the equation would be y equals 0.85x. Your turn. Let's say a competing store opened and their extra toppings were only 65 cents each. Can you write an equation that can tell you the price for any number of toppings? Go ahead and pause the video and try and write your equation. Okay, hopefully you paused the video. We're back from the pause. So again, there's a lot of ways to figure it out. One is we can look at the unit rate that tells us one topping 65 cents, or you could divide any of the y values by their corresponding x. So if I did 1.95 divided by 3, I would get 65 cents. And sometimes we have to do the division process if you don't actually see the unit rate, because sometimes tables wouldn't include the unit rate. So like this might not be here, and you have to use division to find it. So the equation you should have written is y equals 0.65x. Okay. So I have an activity that's really fun, and I think you all will really enjoy it. So if you go to student.desmos.com and then type in the code DJE-D6E, there's a really fun activity that has to do with proportional relationships. It's not necessarily writing equations, but I just found it and it's great practice for proportional relationships anyway. And then the link there at the bottom I'll include in Schoology in the email so that you can just click right on that. And if you have any questions, just email me as you're working on it. I think it should work just fine remotely, but go and do that. It will be really fun. And then the other practice, so Desmos is one of them. The other practice is if you have your Envision textbook volume 1, topic 2. Still, it's pages 103 through 106, and it's topic 2.4. This is where you can do a lot of the practice for these types of questions where you're writing equations from tables. And then again, if you haven't done all the practice that I put up from Friday, the 20th, go ahead and do that because that's a lot of great practice with the same idea. So lastly, if you have your guess or your estimate from how much water that vase can hold, here is shown, so just to explain the picture, the vase was full of water. We dyed it blue just so you could see it easier and poured it into these Pyrex containers that have the ounces marked on them. And so the total number of liquid that was in that vase was 41 ounces. So a Coke can was 12 ounces. That vase was 41 ounces. How close did you get? Message me on Schoology. Let me know. Okay, everyone. That's it. Bye for now.